Okay, so we're going to take a look at some more examples of solving systems by graphing.
All right, another example. So again, this is in y equals mx plus b. So graph both equations, y-intercept and rise over run. Okay, so y-intercept plus 1 right here on the y-axis of 1. And then I'm going to do rise over run. So I'm going to go down 2, right 3. Down 2, 1, 2, right 3, 1, 2, 3.
This is a listening check. Put a box around example 3, the word example 3.
All right, then you're going to do the second one. This one is not equal in y equals mx plus b, so it must be in standard form. And again, look at x and y-intercept if you forgot. So let me cover it up and see if it'll work. 2x equals 9, now I'm going to get a fraction, right? So that means I have to make it into y equals mx plus b. How do I do that? I just simply take this to the other side. So if this is my river, I take this to the other side. It's going to change from positive 2x to what? Negative 2x. So I'm going to have 3y, so I'm just doing this, 3y equals negative 2x plus this 9. How do I get y by itself? Divide everything by 3. It's going to go away. So now I'm going to have y equals negative 2 over 3x. 9 divided by 3 is going to be 3. So now I have my y equals 1. So again, you start off with the intercept, which is positive 3. 1, 2, 3. Positive 3 on the y. And then I'm going to go down 2, because it's negative, right 3. Rise over run. So down 2, 1, 2, run 3, 1, 2, 3. All right, then I'm going to go ahead and draw. All right, so again, if the graphs are the same, they're not the same. If the graphs are parallel, so what does it mean again? They don't ever meet. So this is parallel, which means there are no solutions. Okay, so if this was the equation, this has no solutions. And I just want to make sure that we also understand something that we're supposed to know. If they are parallel, the slope is the same. So I'm going to go ahead and add this right here. Note, if they're parallel, slope is the same. Okay, so take a look at what that means. So if you look right here, what is the slope for this first equation? All right, take a highlighter or a color pencil. It's negative 2 over 3. Okay, what's the slope for the second one? Negative 2 over 3. The slopes are the same, but the y-intercepts are different. It's going to be no solutions. Slope is the same, but the y-intercept is different, no solutions. Because if the slope is the same and the y-intercept is the same, then it's going to be the same line. All right, so this is in y equals again. So if it's in y equals, you're going to do y-intercept and then rise over run. Okay, so y-intercept is positive 3.
This is a listening check. Color in example 4.
So you start off at positive 3 on the y-axis, which is right here. And then you're going to rise and run. If it's not already a fraction, put an invisible 1 underneath. So you're going to go down because it's negative 2. It's always rise and then run. And then you're going to run 1. So you're going to go down to 1, 2, and then run 1. And that's your point.
This is a listening check. Color in the second equation, 4x plus 2y equals 6.
The second equation is not into y equals mx plus b. Now we can make it y equals mx plus b, but we're going to check for x and y intercepts first because that might be faster. Just have to make sure it's divisible. So you cover that. 6 divided by 4, is that going to go evenly? No, it's not. So because it's not going to go evenly, I have to solve for y equals. So all you do when you're solving for y equals is you take this to the other side. So when you cross the river with that's going to be what? Negative. So you have 2y equals negative 4x plus the 6 that's already here. To get y by itself, what do I have to do? Divide everything by 2. So now you're going to have y equals negative 4 divided by 2 is going to be negative 2x. 6 divided by 2 is going to be 3. All right, so you go ahead and graph that. So you start off with your y-intercept, which is at 3. So start off at 3, and then I'm going to go rise over run, which is down 2, right 1, down 2, right 1. And what can you tell me about this? this graph is exactly the same graph. So because it's exactly the same graph, okay, it has the same graph, infinitely many solutions. All right, so infinitely many solutions. So notice that this one is different. It has the same slope. So in order to save you time for whether you have to even graph or solve, you look for the same slope, but it also has the exact same y-intercept. So if it is exactly the same, they look exactly the same, it's infinitely many solutions. If it is the same slope, but y-intercepts are different, so add that in here, but y-intercept is different. Okay, same slope but y-intercept is different, then it has no solution because they're going to be parallel. It's the same thing. Okay. All right, finally, what ordered pair are the solutions in the graph? So the solutions happen what? Where the point intersects are the solutions. So you have to see just where they intersect. So you've got this graph going here, this graph going here. Where they meet at this point and at this point is the solution. So you've got the graph doing this and another one doing that. Where they meet, where they cross, that point and that point are the solutions. So you just got to read it off the graph. This one is -6, -3, -6, -3, and this point here is -1. I'm gonna say, I didn't write it in, so let's just say this is 0.5, -1 and 1/2. Okay, over here, this point is -4, 2. And this point is 2, -2. Okay, so sometimes I give you questions like this. Just remember where they intersect is your solution, and sometimes there's more than one solution. And that's pretty much it. Let's practice.